In this video, I will show you how to build an automatic street light model at home using simple materials like cardboard. And the best part is, we won't use a ready-made board. We will create our own PCB using just 2 components. And if you are new here, welcome! This is lesson 13 of our 24-part series called Arduino for Beginners, where I guide you from the very basics all the way up to building your own projects. Today, we won't just wire components and hope they work. Instead, you'll actually understand why the circuit works, how it reacts to light, and how it makes a decision all on its own, without any code involved. This project is special because it's the first full real application in this series. We are taking everything you've learned so far and turning it into something real that you can touch, test, and show off. But before we start building, let me show you what the final result looks like. What you are seeing here is a small street model with a few lamps. On the side, there is a light sensor that constantly measures the environment. When there is daylight, the street lights stay off. As soon as it gets dark, they automatically turn on. There is no button, no code, and no microcontroller involved here. The circuit itself makes the decision. This is the kind of project that instantly makes electronics feel real. It's perfect if you are just starting, if you are preparing for a science fair, or if you want to finally understand what is going on inside the device you use every day. Now that you've seen where we are going, let's understand how the magic happens. A few lessons ago, you learned how to turn an LED on and off using Arduino and a light sensor. That was an important step. Arduino gives you power, flexibility, and simplicity. But today, we are going a little deeper. Instead of writing code, we are going to wire automation into the circuit itself. On the breadboard here, you can see the complete circuit. When I cover the sensor and simulate night time, the LED turns on instantly. Same result as Arduino, but achieved with pure hardware. So how does this tiny circuit make the decision? Let's take a closer look. Here's the schematic for today's project. We are working with 4 main parts. The LED shows us the result, the 100K resistor and the light sensor form a control system, and the transistor acts like the brain, or more precisely, like a switch controlled by electricity. Let's start the explanation with the transistor. The transistor's job is to control power. It has 3 pins: collector, base, and emitter. Inside a NPN transistor, like the one we are using today, current flows from the collector to the emitter, but only when the base receives enough voltage. If the base is off, no current flows. If the base turns on, the entire circuit becomes active. So think of the transistor as a gate. A very small signal at the base opens the gate and allows a much bigger signal to pass through. This is one of the most important concepts in all of electronics. It's what allows tiny sensors to control powerful systems like motors, relays, and lights. Now the next question is, how does the light sensor control the base? The 100K resistor and the light sensor work together in something called a voltage divider. And the idea is very simple. Different resistance create different voltages. When light hits the sensor, its resistance becomes low. When it's dark, the resistance increases. That change in resistance directly changes the voltage applied to the transistor base. During the day, the voltage at the base is too low to activate the transistor, so nothing happens. At night, the voltage rises above the required level. The transistor turns on, current flows, and the LED lights up. A simple result without relying on logic gates or programming, just voltage doing logical work. It's the kind of thing that makes electronics so satisfying. The beauty of this project is not the final model, it's what you learn along the way. This is the foundation for a more complex project we will build in future lessons. Talking about electronics and circuits remind me of today's sponsor, GF Robot. If you are not familiar with them yet, GF Robot is one of the leading global providers of hardware for robotics and electronics projects. In the online store, which I've linked in the description below, you can find pretty much everything you need for your next build, from sensors and motors to microcontrollers, cameras, and servo motors. I've been doing this for more than 15 years now, and what I really appreciate is how they focus on making high-quality products that are still affordable and accessible, especially for beginners. For example, this Arduino board right here came from the Mind Plus Arduino coding kit, which is the kit we'll be using throughout this series. As you can see, it includes everything a beginner needs to build their first Arduino products and really start learning how electronics work. If you want to get the most out of this course and follow along with the same parts I'm using, I highly recommend checking out this kit. And even after this series ends, you will still be able to use it to build tons of other projects on your own. So a big thank you to DF Robot for sponsoring this series and helping make STEAM education more accessible to everyone. Now let's get back to the project. The first thing we are going to work on is the PCB. As I've mentioned at the beginning of this tutorial, we are going to use only two materials to make it: copper-clad board and ferric chloride. Before proceeding, it's extremely important to understand that ferric chloride is not a harmless substance. You must use protection like gloves and glasses. Safety is very important here. The idea behind this process is actually very simple. Ferric chloride removes copper from the board except for the parts that are protected by our circuit traces. To create those traces, we'll use a permanent marker directly onto the copper according to this diagram appearing on your screen. After drawing the traces, I realized I made a mistake. I didn't write down the connections of the resistor and later on fix it by soldering some wires. If creating a PCB sounds confusing right now, don't worry. I have a full tutorial on how to make PCBs at home where I explain this whole process step by step. Don't forget to check it out. Now we just need to remove all the unnecessary copper. I placed the board into a plastic container and poured in some ferric chloride. Then let it sit for some minutes. After that, I took the board out and washed it carefully. Then I drilled the holes and soldered the components according to the schematic. And just like that, we had a real PCB. Now that the PCB is finished, let's build the physical model using simple materials like cardboard, paper, and glue. Start by cutting the cardboard into rectangles just like you see on the screen. Make sure to follow the measurements shown on your screen right now. Additionally, you can find the measurements, schematic, and other materials in the GitHub repository of this project. The link is in the description. Once everything is cut, glue the pieces together to form the structure of the model. Next, I prepared the lighting. I took 3 white LEDs and soldered wires to each one. Then I connect them in parallel, which means all the ground wires are connected together and all the positive wires are also connected together. To create the street lights, I used paper to form small lamp covers and fed the LED wires through them. Then I glued the LEDs in place on top of the model. And just like that, we had lights. Finally, I connected a 9-volt battery, placed it inside the cardboard base and closed everything up. And as you can see, the final model works exactly as we planned. Pretty cool, right? If you enjoyed this project and want to build even more things with Arduino, you're probably going to like this. I'm currently preparing a full masterclass on how to build drones using Arduino. We'll cover a wide range of topics including flight control, wireless communication, PCB design, and 3D printing. You won't just learn the theory behind how drones work, you'll also build real drones step by step using an Arduino board. If that sounds interesting to you, I have created a waiting list. You will find the link in the description below. Join it if you want to be the first to know when the course is released. And that's it for today's video. I hope you enjoyed and learned something new. If you did, don't forget to like the video and subscribe to the channel so you don't miss any upcoming lessons. And while you are here, I recommend watching the video on your screen right now. It will definitely help you with your next project.